So, good morning guys. We have another problem here. So, this is energy, chemistry for engineers. From this data, we have a chemical reaction of is rhombic. So, sulfur, which is rhombic in terms of its figure, plus oxygen, it transforms into SO2 gas. So, this is the formation of SO2 from sulfur rhombic. The the enthalpy, the change in enthalpy of that reaction standard is negative 296. So it is carefully measured in a standard condition. So that is negative 296.06 kilojoule per mole. And then you have also the formation of SO2. So we say formation because SO2 gas is being is the product of this chemical reaction, meaning the other one is sulfur monoclinic with respect to an oxygen. Of course, I think this combustion also. And then you have the change in enthalpy of reaction standard. You have that circle as an superscript, negative 296.36 kilojoule per mole. Calculate the enthalpy change for the transformation of S rhombic to S monoclinic. Monoclinic and rhombic are different allotropic forms of elemental sulfur. So it's an allotrope, meaning it is a different atomic formation, atomic scale. So anyway, this kind of problem, you only have to derive this S rhombic from the chemical reaction. Of course, that is by actually inverting. Since we need an S monoclinic on the product, so we can expect that we will invert the first reaction, and then of course we will change that chemical reaction into a positive. If we will change this exothermic reaction, it's just if that is a release of energy, so that would inverting that one would be an endothermic reaction, meaning that would be an absorption of energy. So okay, so what we need to do is just may I use a gray ink. So actually what you need is just invert the second one, meaning the SO2 would be producing S monoclinic, the sulfur monoclinic, and then plus your oxygen gas. But again, the delta H for this one at standard would be, of course, a reverse. That is an absorption. That is a 296.36 kilojoule per mole. Okay. And then maybe we can just write the S rhombic at the upper side, or maybe at the lower side. Maybe we can write it here. S rhombic plus oxygen, and then we have a product of SO2 as a gas, SO2 as a gas. Then the delta H, or the enthalpy of reaction at standard state, is equal to negative 296.06 kilojoule per mole. So basically the standard way of doing this one is to add the chemical reaction. When you're adding a chemical reaction, that is a summation of chemical reaction. So when you add a chemical reaction, you only see it that the product, the reactant and the product, if they appear on both terms, they should be cancelled off. Just like this one, SO2 is a product here. Okay, so we will cancel this off. This is a product, and a reactant in the first reaction, and then a product on the second reaction. So we'll just cancel it. Okay, and then we can also see that oxygen as a gas is a product from the first reaction and a reactant from the second reaction. So therefore, we can cancel it. Okay? That's the basic ruling for addition of your chemical reaction. So we can see that, you can now see that what we have is S-rhombic and then turning into, sorry, that would be an arrow turning into an S-monoclinic, which is our problem. And then of course, since this is already the thing or the chemical reaction that we're trying to look at, so therefore we can already add this one. The only problem here, if this will not be the case, so maybe we have to invert this one. Some of this example, especially for reactions with multiple steps. So that's the usual problem. More complex problem is we have to invert, or probably we can add more coefficients. I mean, we can balance probably the coefficients. It's just like balancing chemical reaction. Okay, so if this is already equal, so you have to get your calculator. 296.36. Of course, you have to add because you have added. Usually, it's only addition, meaning we have to invert anything if the product or the compounds that we're trying to look at is not the sum of the chemical reaction itself. So 296.36 plus negative 296.06. So you can expect na diritiya sugad ka dako. Labi na kay naka kilojoules na. Because that is just a rearrangement of atoms. So meanings we are only breaking secondary bonds. So that would be a 0.3, a positive 0.3. So delta H of this reaction, so you can also put like that one. Delta H of that, the enthalpy of that reaction in standard state, that is the formation of S-monoclinic from S-rhombic or sulfur rhombic, that would be a 0.3 kilojoule per mole. Okay, so that would be, if the mass of the sulfur is given, then probably we could compute the exact energy that is in kilojoules, not in kilojoules per mole. Okay, so thank you guys for listening.